Bow your heads, please.
Thank you for this day. Hope everybody has a good day and doesn't get hurt.
Amen. Thank you very much, Jane. Appreciate it. Okay. Now, last week we did corals, but we didn't get to talk about the Oculina coral reefs. And if you'll turn back to page 69 with me for just a minute, because I don't have a picture like that I can get anywhere. So turn back to page 69. On page 69, on that picture, you see the bottom picture on the right-hand side of Florida, up what we would call the northeast side of Florida. You see it where it's marked the Oculina banks. Does everybody see that? Okay, those are coral reefs, and they are up along, here it shows you, up along the north coast of Florida. That's what an Oculina coral looks like. They kind of look like, they say ivory or white, look like trees. And this is what the Oculina reef would look like. Now that's very different from what we have down here. And part of that is because this reef is like at 200 feet deep. So it doesn't have necessarily the symbiotic zooxanthellae that gives our coral down here the pretty colors and stuff. And that could be why it's that white color, because it's so deep that it doesn't get enough light for the algae to live in them. But this is the Oculina coral, and it was mentioned in your text, so I at least wanted to show it to you. And you can really see the difference, can't you? They're very, very different types of coral. Our corals down here, usually you find it between 0 and about 100 feet, the most spectacular coral reefs. You can get some below that, but most of them need more sunlight. Okay. So today, we are looking at the last chapter in the book. So let's go ahead and turn there. I'm using both books again, so you'll have to forgive me. So it is chapter 8, and it is on page 113. And we're looking at the Gulf and the ocean. And the reason we're looking at the Gulf and the ocean is because really, Florida is very small compared to the amount of water that's around us. And for that matter, the water that's on Florida and under Florida and in Florida. But this time we're actually looking at the water around us, particularly the Gulf of Mexico, which is on the west coast of Florida, and the Atlantic, which is on the east coast of Florida. It's funny because my brother and I were talking about this last night. I'm from over here, but I live over there. And I teach here and there. And it's so interesting because the kids over there, I tell them that over here you can walk out on the dock. What's it called? The pier, that's it. Yeah, I tell them you can walk all the way out on the pier and be in 20 feet of water, and you can identify every fish that goes by, and you can see the stuff on the bottom, and they go, oh, no. And then I told my brother, but then when I talk to you guys and I say you go over on that coast, and when you walk in the water, if you get knee deep, you can't see your feet anymore. So the two coasts are very, very different. And I've already explained to you that the reason the Gulf of Mexico is so murky and sandy and stuff is because the Mississippi River is dumping into it. And we have 13 different rivers, 13 different estuaries on the west coast that are dumping into it. And so when you have all these rivers dumping into it, you have a lot of sediments that are coming in. And so there's about 2 days a year that you can actually see clearly over there that I've noticed, and actually see the fish and stuff. Now that doesn't change the fact that there's a lot of life in the Gulf of Mexico. Hang on just a sec, and don't forget your whatever question or whatever. When I was talking to the kids this week, we were all giggling and laughing because we've all over there been to the beach when there were tourists in the water and a manatee swims right by them and they scream. Because a manatee is a very large animal to have just right next to you all of a sudden, and then over there you can't see them coming because the water's so murky. So all of a sudden they're just right there, and you've got this 10-foot animal next to you. And I even had one student that say she was on her boogie board, and when she came down on a manatee and was literally riding the manatee, you know. And so over there, that kind of stuff happens because you really can't see. My brother was saying, yeah, he doesn't like the beach over there because he gets sick of shuffling his feet to kick the stingrays out of the way. And that's how it is over there. There's signs at every beach to shuffle your feet so that you don't step on a stingray, because there are so many and it's so murky you can't see. So the two coasts are very, very different because the Gulf of Mexico is very different than the Atlantic Ocean. I just want you to know that. Yes, Garrison?
When saltwater and freshwater mix, why does it make it murky?
It's not the saltwater and freshwater mixing that makes it murky. It's all the sediments that are carried by those rivers. Because remember, we have alluvial rivers, and we have black water lakes, and we have all that stuff, and all of that's dumping in and carrying with it little pieces. Okay?
They all mix together
Yeah,
on
so
the
it's
floor.
so it's not the mixture of the salt and fresh. It's the rivers carrying all the loads of sediment that they do that actually make it that way. Okay? I know in the other class, we were doing the Amazon River not long ago, and it dumps tons and tons and tons of sediment into the ocean. So rivers carry a lot of stuff with it. And if you saw that river, you couldn't see your toe if you stuck it in. It's really set full of sediments and stuff. So I don't think I'd swim there. Anyway, piranha and stuff like that, I don't think so. Anyway, okay, so because when I would go to the beach on the Gulf side, it just seems like it's shallow forever because the continental shelf is so broad on that coast that I always thought of the Gulf of Mexico like a big bathtub. You know, you come over here and you got waves and you can body surf and you can have some fun and you can get your snorkel on and go out and look at a reef or whatever. Over there, it's murky. You can walk out forever, it seems like, and you're still in this much water. And it's just very different. And if you go out in your boat here, you can go out 3 miles and you can be in thousands of feet of water and go deep sea fishing. You go over there and you're going to go 30, 40, 50 miles and it's still less than 100 feet deep. And it's because look how broad the continental shelf is on the west coast. You see it? So I was shocked when I first learned that the Gulf of Mexico is over 10,000 feet deep. I'm thinking, whoa, wait a minute, I thought it was a big bathtub, you know, with no waves, basically, compared to this coast, and it was so shallow, but it's not. It gets very, very deep in the Gulf, and so there's a lot of things that live there that I had no idea. There's a lot of things that live around Florida that I had no idea. If you turn, and we're going to go back and forth a lot today, so just keep up with me, okay? If you turn to page 116, you see in the Gulf of Mexico, you have the West Florida Shelf, which would be the continental shelf. And below Florida, you have the Florida Straits. But on the left of all that, you have Sigsbee's Deep. And then you have the Mexico Basin. And it tells us here, excuse me, that the base of it in the deepest parts is over 10,000 feet deep, 10,200 feet down. And then it describes some of the differences. And at the bottom paragraph in figure 8.3, God bless you, it says that off the northwest coast of Florida, cold water spews from major springs and seeps. Cold, fresh water pours forth from the deep seafloor, and cold salt water seeps from the base of the slopes. And the slope that it's talking about is this slope here coming down. This is called the continental slope. You have the continental shelf and the continental slope. And at the bottom of this, you have some seeps. And we're going to briefly look at some of those communities, those ecosystems today. Within the Gulf of Mexico, this is what your basic currents are. And notice that this all comes together. Notice this goes in this direction and this goes in this direction. And that comes out and forms the Gulf Stream, which we're going to look at in a minute. So I just wanted you to see that. I had a student ask, what's an eddy? An eddy is when you get an area where it just goes around and around. It's too big to actually be a big whirlpool, but the water just kind of keeps moving in a circle. And so I guess the Sargasso Sea would be a huge eddy. But anyway, and you guys read about that. Oh, something else that's not in your book, and I just wanted to mention. This is Flower Garden Banks National Marine Sanctuary, and it's in the Gulf of Mexico. It's up here. Notice here's Texas and here's Louisiana, and it's up in here on this part of the shelf. So look right here. You can see here's Texas, here's Louisiana, and these are the reefs, the Flower Garden Banks. And check this out. Look at that reef. I mean, that looks like something you'd see in the Keys, doesn't it? And that's off the coast of Texas and Louisiana, so you can see why it's a national marine sanctuary. And there's two basic places that it comes up, where the continental shelf comes up, and this is where you see these coral reefs up there. So I just wanted to point that out. Okay. Once again, when these currents come out through the Straits of Florida, they produce the Gulf Stream. Think of the Gulf Stream like a warm water river within the ocean. That's really what it is, a warm water river within the ocean. And they can actually put dyes in it, and then you can watch the dye move with it. You guys have all seen Finding Nemo, right? Do you remember when they caught the one current to get to Australia? Remember that? And they kind of rode the current, right?
Where's the East Australian current?
There you go. Thank you. I haven't seen it in a long time. Thank you. And so the Gulf Stream actually is like that. It's a current, a warm water current. And what's interesting is where it ends up here, like in Great Britain and Iceland and stuff, where the current itself ends, it will have warm water and tropical things will live there, sea anemone and stuff that you wouldn't necessarily see in cold water otherwise. And it'll be only in that cove where the Gulf Stream ends, and then everything else will be different. So it's very interesting, actually, the Gulf Stream itself, if we had time to just ponder that. And then the third thing we're going to look at in this chapter, so we're going to look at the Gulf Stream, we're going to look at the Gulf of Mexico, and then the Sargasso Sea. And that's the three things that this chapter focuses on. So let's go back to the Gulf Stream now. It tells us that there are a lot of different fish. It lists in your book. And the best way I could come up with pictures of these fish is from a charter service, so you'll have to forgive me. I just used their pictures, okay? One of the fish that it mentioned was the dolphin. Now, what do most of us call this kind of dolphin? Because you don't want to be told, you're eating dolphin tonight, and everybody goes, oh, I don't want to eat flipper. So what do we call it usually? Mahi. Most people, like if you go to a restaurant or whatever, they'll say it's mahi-mahi. And they call it that because they used to call it dolphin, and people wouldn't eat it because they were afraid they were eating flipper. You know, like, oh, I'm not eating a dolphin. Well, I understand that. I had a student yesterday say, what's the difference? There is a difference. A dolphin is a mammal. It nurses its young. It's warm-blooded. They talk to us. You know what I'm saying? Whereas this is a fish. It's a fish, you know? So there's a big difference. Anyway, have any of you ever caught these? Okay.
I do believe my mom actually caught one.
Okay, and when you see them in the water, sometimes they can be very colorful and sometimes they can be not so colorful. It's interesting how they change colors, isn't it? But they can be very beautiful, and that's the way we paint them because we like them when they're real colorful, don't we? But we like to eat them too, right? So, have you ever seen one of these? A marlin. Have any of you ever seen somebody catch a marlin? You have. Okay, did it come up and dance? Yeah. It did. I said that to the students yesterday, and they're all looking at me, what do you mean it danced? Marlins, one of the reasons people like to catch marlin, it's a big fish, okay? Most marlin are good size, way over 6 feet, you know, and average more like 8 or 12 feet.
Yeah, it says here it can commonly grow to lengths of 8 feet.
Yeah, well, I've personally seen one 12 feet from the back of the boat that my dad hooked, and it danced for us. And they come up and they go like this because they're trying to get away, and I understand that. So they stand up on their tail and they dance backwards away from you. They're an incredible sight to see. It's well worth seeing a marlin. And I understand it trying to get away. I'd try to get away too, right? I mean, that makes sense. And we actually didn't catch that when it broke the line. It hit my dad's lucky pole and it had 60-pound test on it, and we've got this 12-foot marlin on the 60-pound test, and we're all going, look, because it's not coming in. So better look while you can and enjoy, you know. And it was beautiful. It was really magnificent. Yes, sir.
You know why they call it the white marlin? Because the other one's called a swordfish and the other one's called a sailfish. Why is that called the white marlin?
Because that's a blue marlin there, and they're just a little bluer, I guess. But and the stripes look a little more distinct, but there's probably other slight differences. Because there's a blue marlin, there's a white marlin. Now, when you guys caught them, did you catch the marlin, or did you just see it dance? You caught it?
Yeah, we caught it.
Did you guys release?
Yeah.
Yeah, they don't keep them anymore. They used to. Personally, when I used to live over here, when I first married my husband, we would go to the beach, and on the way home, we would always buy a piece of smoked marlin, eat it on the drive home, because we always drove a couple hours so we could take our dogs to the beach. You know, you can't do that in Palm Beach, so we'd all go up to Fort Pierce, excuse me. And back then, you could buy smoked marlin, which was a very tasty fish, but too many people fished too many marlins, and so now they catch and release. So if you catch a marlin, you turn it back loose. And that's true of most billfish now, I think. And when I say billfish, you're looking at them there on page 117. So you've got the swordfish, you've got the sailfish. Notice they have that long bill, and so that's why they're called billfish. But they tend to be game fish. People go out to catch them. Yes, sir?
Most of the people keep the swordfish though.
They'll keep the swordfish, yes, because you can go buy swordfish in the store to eat. So yes, you are allowed to keep them. And they get rather large too. Notice they get 400 to 500 pounds. I don't know about you, but I would not want to reel something in that was 400 to 500 pounds. That's a lot of fish. Yeah.
Yeah, another thing on that. It says that they used to, the average, before they were overfished, they used to be 200 pounds. But now they're a little less than like 50.
A little less than 950. Which are you talking about, sweetie?
It says
The swordfish?
Yeah.
Oh, okay, that's what I meant. Okay. Typically weigh less than 50. Okay, I gotcha. So they're fishing them out. It happens. And you're given the word at the bottom of that. It says big fish in the pelagic ocean. When you hear pelagic, it means that you're swimming. A pelagic fish is in the water column swimming, whereas something that lives on the bottom is a benthic fish, because the benthos is the bottom. Remember that from when we talked about lakes? Okay, so anyway, and then here's your swordfish. Your wahoo, that's what they smoke now that I eat. That's my favorite fish to get now when they smoke it, is wahoo. Smoked wahoo is a very tasty fish. Tuna, I like tuna, you know, the seared kind, not the canned kind. I'm very spoiled. Sushi type tuna, sushi grade tuna. Anyway, those are all pelagic fish. They swim great distances. It also mentioned cobia. These fish can be about 5 or 6 feet long. There's a bonita. That tends to be a very bloody fish, and so does a jack. So if you hook one of those, frequently you'll get sharks coming up behind it. Redfish. Do they fish for redfish over here? No. Okay, on the West Coast, that's a big thing, redfish. And Spanish mackerel. A lot of Spanish mackerel on the other coast. Are there Spanish mackerel on this coast? Okay, Spanish mackerel, lots of them on the other coast. As soon as I saw it, I'm thinking of my youngest daughter, who is now married, but when she was a kid, she used to like to go mackerel fishing, and as soon as my husband would get to where the birds were coming down, so he knew he was trolling through the mackerel, and then he'd give her the pole, and she'd, hook one, and then the whole boat, all of us would go, tip up, because she'd be down like this, and go, oh! And so every time I see a mackerel, the words come in my mind, tip up, So, and then the king mackerel, you do get it on this coast, and they're bigger. And that's why they're called king mackerel, or kingfish. If somebody says to you, you're eating kingfish, or you caught a kingfish, that's the king mackerel. And that's a much larger fish. Regular mackerel, about this big, average. Kingfish, about that big. So it's a much bigger fish. And then when you get closer in, the reefs within the Gulf of Mexico, these are some reef fish you'd see over here too, but remember when the lady from up in the Panhandle that we watched was talking about the gag grouper was only this big? Well, there's your gag grouper. That's what it looks like when it grows up, and people go out and fish it. Amberjack, another very good fish, smoked. Okay, if you ever see smoked amberjack or smoked wahoo, grab the wahoo, but if you don't have a choice, smoked amberjack is good. I'm just going to tell you that. Oh, and just to give you some real pertinent information, if you ever get a piece of smoked fish, don't eat the skin. Don't eat the dark parts, which would be called the bloodline, unless you like something to taste horribly fishy, okay? But if when you get it, you cut off the skin and you cut out the bloodline and you only eat the white parts, it will not be fishy, yucky, gaggy. It'll taste really, really good. And I think part of the reason people don't eat fish is they've had fishy fish, they didn't know to cut out the bloodline or whatever, and then they think, ew, fish is awful. You haven't tasted good fish if you feel that way, because if you eat a good light piece of fish without bloodline, it's excellent. It's much lighter than chicken or something like that. So just make sure if you ever get a piece of smoked fish that you cut off the skin or pull the skin off and cut off any dark, and then cut out the bloodline, which will be the dark part. Just eat the lighter parts, okay? Okay. And then the triggerfish you guys have probably seen over here. You guys have all seen snappers, right? All the different variations of snappers. And then if you get closer in, these are the fish that you'd see more right along the coast. Bluefish, flounders, trout. The kids over there were like, oh man, we catch sheepheads all the time. Do you guys get those over here? Yeah. Okay, so the sheephead, pompano. I see people off the beach over here grabbing sand fleas and catching pompano right off the beach with the sand fleas as bait over here. Okay, so I've seen that. Yep, so, okay. Yes, sir.
My dad one time, he was in Peru, and when you said snapper, it reminded me of piranha.
Oh.
He had 2 piranhas he was holding the boat. He put the one to the other one's neck, and well, I guess it snapped. He went right through his neck.
Oh my goodness.
Yeah, they're very
Thank
shiny.
God we don't have piranha. Now, we do have in the Gulf of Mexico the toadfish. And I don't know about you, that is, see its eye here to get an idea? That's a really poor little ugly fish, only his mama could love. You know, I mean, looking at that going, that's just an ugly fish. Now, I thought this was a pretty cool picture, so work with me here, okay? See the red? The red is the highest salt content. Down here at the purple, that's the lowest salt content. And then yellow is pretty high still. Okay, now notice there's red right here. Do you guys see this? This is the Sargasso Sea, and that's a really interesting place. You're going to see today there is a gyre, which is one of those big currents that goes, there's actually 4 currents, one this way, this way, and this way. And what happens is they spin around and they make a place called the Sargasso Sea. Now the Sargasso Sea is right here, and it's this huge lens of water. And when I say a lens, it literally floats on the rest of the ocean, and it floats 3 feet higher than the ocean around it. Okay? Pretty cool, huh? And it actually, it's separate from the water below it too. It separates itself because it's more salty and it's warmer. What's happening right there is it evaporates out. The water evaporates out, and so it gets saltier and saltier right there. Now, it's called the Sargasso Sea because when you get there, let's say you and I were out there in a boat, all of a sudden you'd see like this pasture of Sargasso seaweed as far as the eye can see. That's the Sargasso Sea. And sea turtle babies go there to grow up. I think that is so cool. They go there and they hang out in the seaweed, and that's where they grow up. And then when they get about dinner plate size, they come back to the places like Florida and other coasts like that. So that's a really salty area right here in the Sargasso Sea. Notice the Mediterranean Sea is much saltier than other places. And that's probably because of the evaporation that goes on, and it's only got this little outlet right here. Then the yellow parts, you notice there in some of these other gyres, okay? And so you might have similar situations as what's going on here. Now look at the areas that aren't as salty. You see down here in the purpley colors? Look right here off of the northeast coast of South America. There's a real freshwater area there. What is possibly causing that fresh water that's being dumped into the ocean right there in northeast South America? Can anybody guess? Think of a big river. The Amazon. You ever heard of the Amazon River? Well, you've heard of the Amazon rainforest. There's a river running through it. That's why it's a rainforest. Okay? And so that is being dumped here. Look right here. What river is making this low salt area? Yes. Good girl. The Mississippi River is dumping in right here, isn't it? The Great Lakes are dumping out here. Do you see all these areas where you've got some freshwater intrusion, and you've got a lot of meltwater and things coming out in here? So you've got a much lower salt concentration in certain areas of the ocean than in others. I just thought that was interesting to see how different the salt content could be in different places in the ocean. And just so you know, this goes to 40 grams per kilogram to 30 grams per kilogram. So it's not a huge change, but there are some differences because of the addition. Now your book goes on to tell us that there's another thing that is interesting about the water, and that is, does anybody want to guess what those are that you're looking at there? Okay, I'm going to start this picture with the idea of a soda, because I think all of you have had a soda before or seen one. Right, okay. If you have a soda that's cold or you have a soda that's warm, which one are the bubbles going to come out of fastest? The cold one or the warm one? Think, which one's going to go flat faster? The warm one. And that means the bubbles came out when it's flat, right? Your bubbles are gone, correct? So a cold one keeps its bubbles better because the bubbles can't escape as quickly out of the cold soda as they can out of the warm soda, right? The ocean is the same way. The colder ocean water holds more oxygen and other gases than the warm ocean water, just like a soda. Okay? Now, that's important because there are critters, little microscopic critters that live in the ocean, and they need the oxygen. They need the carbon dioxide. They need the gases. And if the water is too warm, those gases come right back out, just like the bubbles out of a hot soda. But if the water is cool, more of that gas can stay in the water. And that's so important because these little guys are called phytoplankton. And let me just show you that word. You won't see it again until biology. It's phytoplankton. Now, this word plankton is worth you knowing because plankton is anything that floats around in the ocean and can't fight the current. So it can't swim against the current on its own. So that means a jellyfish would be considered a type of plankton because it can swim, but it can't swim against the current. Does that make sense? And you guys have probably heard before that the word planet actually means wandering star, because they seem to move, the planets seem to move faster than the stars. So they call them planets as wandering stars. So plankton, that root word means wanderer. And that's why they call them that, because they can't swim against the current. They just kind of wander around in the ocean being pushed around. Does that make sense? Okay, so this word root, phyto, means plant. So these are phytoplankton, which are little tiny microscopic plants. There are also little tiny microscopic animals that are called plankton, and they stick that in front of it. And so that tells you they are animals that are little tiny and float around in the ocean, zooplankton. Okay? Now, just like on land, the bottom of the food chain are little tiny plants. Just like on land, the bottom of the food chain, the plants get the sunlight, and they make food from the sunlight, and then we or cows or whoever eat the plants, and then let's say the cow eats the plant, and then we eat the cow. You see how it goes? That's called the food chain. Well, in the ocean, the gases are super important because otherwise the little tiny plants can't grow. Phytoplankton. Once the little tiny plants can grow, then the little tiny animals can eat them. Once the little tiny animals eat them, then the little tiny fish will eat those. And then the bigger fish will eat the little tiny fish. And then the bigger fish will eat those little tiny fish. And you get the drift, right? So fishermen know to fish where they have this cold water coming in because there'll be more fish in those cold water areas. Believe it or not, I'm going to use one that I think you'll know, mahi-mahi. A lot of people eat those, dolphin, mahi. Mahi actually go north in the summer and come back down. Did I get that right? I know they go north for half the year and come back down, and they're following the cold water currents up there because there's food up there, and then they come back down here. So anyway, phytoplankton. And these are diatoms, which are phytoplankton with little glass houses. And these guys actually make about 80%, 75 to 80% of the air for planet Earth is made by these little guys in the ocean, which when you think about it is rather amazing. The next lesson is talking about currents. And we're told here that the currents we see in the ocean are caused by the sun's warmth, because when the water warms up, you get this right, it becomes less dense, and when the water is cooler, it becomes more dense, so it sinks beneath the warmer water. And so the sun's heat does it, the gravity pulls on it, that helps with currents, and the wind on the top actually pushes the water along, and then when it gets pushed along, something else has to come in its place, doesn't it? So you end up getting a current that way. Now, just ever so briefly, the fun fact talked about Matthew Maury. He lived in the 1800s. How many of you have ever heard of Matthew Maury before? Nobody. Okay. As Christians, we should know who Matthew Maury is because he was an outspoken Christian and he is considered the father of oceanography. So even people that don't like Christians and don't like anything about us have to admit there's a lot of great scientists that were really outspoken Christians. This one's one of them, okay? And Matthew Maury, it actually tells you briefly there, Matthew Maury saw in the Psalms that it said that there were paths in the seas. And when he saw those words, he said, if God says there were paths in the seas, there have to be paths in the seas. And he went looking for them. And he found the currents in the seas. That was the paths in the seas. And he mapped them. So he's considered the father of oceanography. Isn't that cool? So he got it right out of the scripture. And there are other great scientists that have gotten words out of the scripture and then gone and looked for the things and found it to be so. So it's just our lack of being able to interpret the scripture scientifically that we have problems. It's never the scripture, it's us. So anyway, there are surface currents, there are lower currents, but generally we see that the currents in the northern hemisphere go clockwise. Now you guys read this already. Did that bother anybody? In the southern hemisphere, the currents go counterclockwise, and in the northern hemisphere, the currents go clockwise. That's the opposite of the hurricanes. Who noticed that? You guys didn't even notice that. As soon as I read it, I went, wow, Remember, hurricanes in the northern hemisphere spin counterclockwise. But these gyres, which are just really big currents, they spin clockwise in the northern hemisphere. I thought that was weird because it's the opposite. And the same is true in the southern hemisphere. Now, the other thing that's really kind of cool about this is you notice because these currents go clockwise in the northern hemisphere, look what happens. The water that comes by Florida is warm because it comes from closer to the equator. So we have warmer weather because we have warmer water. That's that Gulf Stream. It's warm water, and it goes all the way up into the northern Atlantic and warms up the coast of England where it ends because of that warm water that's there. And I've been told that at the cove where the actual Gulf Stream ends, they have tropical marine life in there, even though it's in England. Only in that one cove, and it's because that's where the Gulf Stream ends. If you do the same thing and look at California, look what happens. The water comes from the Arctic area and comes down the coast of California. So if the warm water coming up from the equator keeps us warm in Florida, guess what this cold water does coming down the west coast of the United States? Keeps it cool in California. So has anybody here ever been swimming in the Pacific near California? Was it cold? Freezing, was it cold? Yeah, they're both going. Yeah, that's just how it struck me. We went there on our honeymoon to the Pacific. I touched that water and I go, why does anybody want to get in this water? I'm a spoiled Floridian, you can tell, okay? But it's cold, isn't it? It's like spring water. You know? And that's because that water is coming down from the polar area in that region. And that's why over there a lot of people don't even have air conditioning in California, because at night it gets down, 60, 70 degrees every night because of the ocean. Isn't that weird? Because it's real hot in the daytime, real cool at night. So anyway, and that's got to do with the ocean because the oceans affect the weather, as we've already seen, right? Okay, let's see. This is showing you the Gulf Stream, and this is the heat in the water. And you can see here this warm water as it's moving up towards Great Britain, where it ends. And so that's just showing you the heat in the Gulf Stream. This is showing you upwellings. The red is warm water surface currents, and then when it gets up here, it cools off, so it sinks, and it comes back south towards the equator. And then as it does this trip, it warms up again, it comes back to the top, and then it flows back. Well, where this cold water comes up, that's called an upwelling. And you read a little bit about that. And when we have, it's at the very end of lesson 25 in the special box, the surface currents, and it talks about upwellings, and it says that when the cooler, nutrient-rich water from lower in the ocean is able to rise up and fill where the warmer water is moved, it's called an upwelling, and that brings all that food to the surface so that there's a lot more fish. So fishermen actually fish where the upwellings are because they know that there's going to be a lot more food because of that cold water that's full of nutrients and gases. And then they're able to, that used to confuse me because I'm thinking cold, why would you want to fish where it's cold water? But that's why, and it really starts with the gases. Okay, so remember the soda picture. And those big swirling currents are called gyres. G-Y-R-E, and then S if you're plural. Gyres? Everybody say gyre. Gyre, good. And that sounds like giant a little bit, doesn't it? But it's gyre. And those are those big circular currents that are going clockwise in the northern hemisphere and counterclockwise in the southern hemisphere. Now I want to do this experiment with you, so you guys are going to help me, and then we'll play the game. So don't put your book away. Don't put your book away. I need your help. On page 104, which it's, you're right across from it in your version, there's an experiment, and this experiment is called observing currents. And this is cool, but I am definitely going to need Miss Michelle's help and your help. So you guys are going to help me. First, we're going to fill a bowl with cold water and a jar with warm water. This has got warm water in it, so I'm going to pour the warm water into my little bottle. I wanted to find a bottle that was small enough that I could get my finger over the top, and this one is. Okay. I got water in here, warm water, and I'm going to have weird colored fingers for the rest of the day, but it's true yesterday also. Okay, so I'm going to put a couple drops of neon food coloring in there. Okay, I'm going to go like this. All right, so this should be purple. Okay, now what does it say? It says, number 3, place your finger over the opening and put it on the bottom of the bowl and then remove your finger. So I'm going to put it all the way at the bottom. Do it this way so you can see. How's that? And then I'm going to move my finger. Now, can you see what the water's doing? Here, this might help. Hang on. Does that help?
Yeah.
Can you see? Can you girls see? Can you see? Okay, because I know the white behind it helps. Do you guys see it? It looks like it's pouring up. Can everybody see that?
Yeah.
The water really looks like it's pouring up. Nolan, can you see it from back there, honey? Okay. Now, what are we learning here? That warm water is less dense than cold water, and it rides on top of cold water, doesn't it? Right? So that's what we're seeing there. Wow, and it really is, it literally is pouring up and going across there. Now let's see what we're supposed to do next. Because this is part of why currents exist, is the warmer water goes to the top, the colder water goes to the bottom. Then it says, empty the bowl. Yes, if you will just dump that out, that's our cold water. Now I have cold water in here. And Miss Michelle's going to pour that out, and then we're going to put some warm water in there, and we're going to do the opposite. So I'm just going to make this a little purpler. Purpler, is that right? Did I say that right? Purpler? It's not a word you use very much. Okay, so we'll make this a little more purple. That sounds more like English. And let's see, we're going to need the warm water. This is our warm water. And this time, we're going to fill the bowl with warm water, the bottle with cold water. We already did the coloring, although it's the same color. We didn't make it blue. Thank you very much. And now we are going to place it just under the surface. So we're going to go like this. You know what? I'm going to speed this up. Okay, there's our warm water. We have to do this again. But I think it's cool. I want them to see it. Okay, this one goes at the top, right? Yes, just under the surface. You ready? This is cold water. Oh, and it's burning my hands because the warm water is really warm. Can you guys see what's happening? Here, let me do this again if this helps. Whoops. Can you see it? Yeah. When it comes out, it's really burning my fingers. When it comes out, it's going straight down, isn't it? Yeah. Okay? And I'm taking my fingers out now. Okay, can you see, guys, that it's at the bottom? Can you see all the cold water's at the bottom? Here, I'm gonna be bad here. There. What do we see happening? Cold water sunk to the bottom, didn't it? Okay? Now we've got to do this one more time. It says 2 more times. We're only going to do it one more time. Let's see if we can use this. Fill the bowl with plain water, fill a bottle with salt water, add a couple drops of food coloring to the salt water. So I'm going to, it's too hot. Go ahead, just dump that.
I will make it as hot next time.
No, it was perfect. I just don't want to stick my hand in it that long. Let's see, I'm going to grab a cup. I need to make salt water. Was this worth it though? Are you guys enjoying seeing this? I think it helps. It helps me. I'm still learning all this stuff too. Remember, I'm a cell biologist. Thank you. And we're just supposed to put regular water in there, right? This is our regular water. Okay. This is our salt water. I'm going to put the salt water. Is that a kid? Sounds like a happy kid. Should we use blue this time? Okay, I'll do blue this time. Just for Sasha. Where's your sister? Oh, she went. She had to go someplace, didn't she? No? I'm sorry. I shouldn't have asked. I was being bad. I was just worried about her. Okay, now what are we supposed to do here? We are supposed to add a couple drops of food coloring, hold this below the surface. So this is the salt water, okay? And I'm going to put it here. This time it's not burning my fingers. You know what? I'm going to put more water in there so they can see it. Oh, that's cold. Oh, this is lukewarm.
Here, I'll come behind you and stand with your thing up and then you can.
Oh, no, that's okay. I can do it. Oh, well, here. It's not a problem. All right, you guys ready? Okay, we got to make it so you can actually see. Can you see? It is, isn't it? Isn't that interesting how it's really pretty. Isn't it? It's really very pretty. Can you guys see from that angle? Yeah? And then I'm going to do it this way so you can see. It is, isn't it? And which is salty or fresh water right on the top? Fresh. Remember, the blue is salty. Look where it's going. It's going right to the bottom, isn't it? Isn't that funny? Mm-hmm. Okay, are we good? I'm just going to pour it out now. Let's see what it does. Yep, still going straight to the bottom.
Wow.
Very cool. Okay, we good? Okay. I can save this salt water. Alrighty, I'm gonna.
How do you can put your computer up there?
We'll just go like this. That was a good point. I'm glad you said something. Okay. So, I'm going to go ahead and get ready for your game. If you do the same thing and look at California, look what happens. The water comes from the Arctic area and comes down the coast of California. So if the warm water coming up from the equator keeps us warm in Florida, guess what this cold water does coming down the west coast of... Now, we talked about equating the ocean water to something like a soda. We said that if a soda was cold, it didn't lose its bubbles as fast as if it was warm, right? And so cold water actually has more life in it because it has more gases in it. And the gases help the little tiny microscopic, actually plants first, but there's also little tiny microscopic animals, God bless you. We call the microscopic plants phytoplankton. It's all plankton because it floats around in the water, okay, wanderers. But there's also zooplankton that eat the little tiny plants. So they're little tiny animals, and then you have little tiny fish that eat the little tiny plants and animals, and then you have a little bigger fish that eat those fish, and it keeps going bigger and bigger. So in other words, that cold water carries nutrients with it, big time. Okay, a matter of fact, fishermen like to fish where there's an upwelling of this cold water and we're going to go there because it's in what we're starting with. And so they'll fish there because there's more big fish there because of that nutrient-rich situation, because of the cooler water. Okay, so, and then we talked about currents, and I'll tell you what, if you want to open your book to the last page of lesson 25, I just want to go back there for a minute. Remember, all of these currents, these are surface currents that are shown here, and we call these big circles that these currents end up making. Do you guys know what they're called? It starts with a G?
Gyres.
Gyres, good job. Everybody say gyres. Good job. Gyres. And so we have two big gyres in the Atlantic. There's two big gyres in the Pacific. There's one gyre in the Indian Ocean, and therefore there are 5 gyres that we see worldwide. They affect the weather of the land that's near it because, like, as the water comes up from the equator, it actually warms the whole east coast of the United States comparatively. Whereas on the west coast, the water is coming down from the Alaska area, the Arctic area, and therefore that cold water current on the west coast actually makes California have colder weather. So these gyres actually affect in many ways, but that is how they affect in weather. And then last week, I hope you enjoyed the experiment as much as I did, where we saw the water seem to be pouring upward, didn't it? And so we saw last week that, you tell me, is salt water or fresh water, which one sinks? Salt water or fresh water? If you have salt water is more dense, so it sinks. And is warm water or cold water denser? Which one sinks?
Cold.
Cold water sinks, just like cold air sinks. hot air rises, the hot water rises over the cold water, doesn't it? Okay? So we saw that last week. Now that plays into density currents, and we really didn't get into that last week. But density currents are actually currents that go this way, up and down, rather than this way, okay? Like I said, we didn't get to this last week, but I just want to show you this. The density current, it tells us here that we have cold air, all right? And so you have a cold surface with this ice on it, but this ice is kind of melting, but there's still ice there. As the surface water gets colder, it becomes dense and it just sinks, okay? And so that's one way of getting a density current. Notice that the density currents change in density rather than the wind. Okay, it's caused by changes in density rather than the wind. Remember, the surface currents are caused by the wind. This is caused by either the water being colder or saltier, okay, and then they sink. And then it will mix the, not only the heat, but the gases and the nutrients, which feeds things. So you have these currents that not only go to the gyres going on the surface, but underneath you have currents that literally are hot, so they're on the top, and then as they go to the Arctic, they cool off, so they go down, and then they go down, and then they come back up someplace else when they finally warm up. And as they do that, it circulates things this way, okay? So you got surface currents going this way, and then you got density currents going this way. So God's worked it all out that all these things will mix. I don't know if you realize this, but if things didn't mix, all the nutrients and the waste products would end up in one place, and the other stuff would be kind of void. And so without that mixing, we would probably kill the Earth's oceans because it needs to be mixed. Just like we said that if the winds didn't distribute the heat, that part of the world would just be a frozen blob and the other part would be a big desert. Okay, so this mixing is very, very important to life on Earth. Now, in that little section at the end of lesson 25, surface currents, it also talked about an upwelling. And that's going to apply to what we're learning about today. When the wind blows the warm water away from an area, just like we had where the hot air rises and the cold air comes in, where it's left behind, here when the warm water is pushed out of the way, the cold water is able to come up in its place, and that's why it's called an upwelling. Okay? And like I said, upwellings are places where fishermen want to fish, because there'll be a lot of big fish there, because the little fish and the little guys are there, so the big fish are there to eat them. And so fishermen actually wait for these upwellings because this is really good for them. And once again, this just shows that the deeper, colder water is nutrient rich. So as it brings the stuff up, the little bitty guys, then the bigger guys are there to eat it when that's pushed away by the surface winds. Okay, we already talked, those are your 5 gyres, and we already talked about that. So let's get to El Nino. El Nino. Actually, I want to show you something. El Nino is rather confusing. Did you guys find El Nino just a little confusing? Okay. So I got a couple of little video clips because I thought they might help us. Next, I'm going to show you something from Australia.
Warmer or colder than average ocean temperatures in one part of the world can influence weather around the globe. Boggles the mind, right? Here's how it works. During normal conditions, trade winds, which blow from east to west, push warm surface waters towards Asia, piling it up in the western Pacific. In some years, though, the trade winds weaken. The warm surface water moves eastward and produces upwelling of cold water off the coast of South America. Climatologists call this El Nino,
which affects the fishermen.
Its climate impacts show up mostly in the wintertime over North America. The warmer ocean fuels an intensification and southward shift of the jet stream. This brings flooding to the southern United States and warmer, drier conditions over parts of the Pacific Northwest, northern U.S., and Canada. But eventually, those trade winds pick up again and sometimes become even stronger than normal. When that happens, they blow the warm water back into the western Pacific and restart the upwelling of cool water towards the surface in the eastern Pacific.
Then you have La Nina.
These strong trade winds are a signature of what is called La Nina, unusually cold conditions in the tropical Pacific that displace the jet stream northward. La Nina can lead to drought in the southern U.S. and cooler temperatures, heavy rains, and flooding in the Pacific Northwest. El Nino and La Nina together are part of the cycle that influences extreme weather and can impact food production, water supply, and even human health, not not just in the U.S., but in many parts of the globe.
Okay,
I have a question.
I'm going to show them one more, so don't turn the, well, yeah, you can turn it on. Go ahead, and then we'll turn it off again. What's your question?
Does one of those, does La Nina or El Nino produce more hurricanes?
Oh, definitely,
The
definitely.
Which one?
It's where it produces more hurricanes. Both of them produce more hurricanes, but it's where. And I'll look, it's probably in the text, but let me
Okay.
show them one more thing. But yeah, it definitely affects hurricanes, and that's why the book said that the last really bad El Nino claimed 2,100 lives in the United States alone. It really does affect. Let's see if I can do the same thing. Let me try Control. Nope, it's not going to work on that, it's too big. Now, the one we just saw was from NOAA, which is the United States version. Now I'm going to show you an Australian version, so when you hear the Aussie voice, you'll know why. And I kind of like this one because the guy's into dogs, so just let it go. But this guy's called Climate Dog.
The El Niño Southern Oscillation, or ENSO, has a big influence on Victoria's climate over winter and spring. The Pacific Ocean trade winds blow from an easterly direction, pushing moist air towards Australia. This
Does that
moist
mean that
tropical
warm
air
water?
is a big source of rain across eastern Australia, including Victoria.
And that's where this guy lives, is in
But
Victoria.
ENSO's behaviour can vary from year to year. During La Nina, ENSO chases greater amounts of moist tropical air across Australia. Many La Nina years have seen higher rainfall in Victoria during winter and spring. During El Nino, ENSO changes his mind and drives warm, moist air towards South America instead. El Nino years have often resulted in drier winter and spring periods for Victoria. Each year, climatologists follow ENSO's behaviour, providing us with a potential rainfall outlook for Victoria. So ENSO is definitely an important dog to keep an eye on.
El Nino, let's see, it told us here that in 1997 and 98, there was a really large El Nino. It was large enough that the energy in the water was equal to 1 million atomic bombs, the size of what hit Hiroshima. So when you've got the warm water current over there, remember it's bigger than 1.5 times the United States size, and it's like 300 feet deep. And it's like a lens of water that's separated from the water around it because it's so much warmer, like up to 14 degrees warmer than the water around it. And because it rains right into it, because it's warm and it's evaporating and then raining back into it, they say it's a lower salt content, so it's low salt and warm. Therefore, what's it going to do? It's going to float to the top, isn't it? Right? So the colder, saltier water is underneath it and around it. And so that's a lot of energy to be in the oceans, and that can cause a lot of hurricanes and stuff. And it says that the increase in hurricanes in 1998 had an estimated 2,100 people died because of the El Nino in the U.S. alone, and $33 billion worth of property damage from severe storms. It definitely increases hurricanes, okay, and depending on which one you get. And you just saw that it causes drought or rain in different areas depending on what's happening. And it showed you in the United States and Canada how on the west coast it affects, and then it showed you in Australia, on the east coast of Australia, how it affects. So depending on what you get, as far as El Nino or La Nina, and remember, La Nina is the cold water current, El Nino is the warm water current. This red shows you the warmth, okay? And so that would be your El Nino. Now remember, these Chilean fishermen and stuff, and the guys that are fishermen over here, they want La Nina, don't they? Because that cold water upwelling will bring fish. So they kind of want El Nino to be pushed off and get La Nina going on. Okay, now do you remember from your reading how often does this go back and forth? And that's why it's called ENSO, which is El Nino Southern Oscillation. Oscillation means something goes back and forth. So it's called oscillation because it goes back and forth between El Nino and La Nina. Yes?
I know how many years it goes. It's
Go
3
ahead.
to 7.
Very good. It has a 3 to 7 year rotation. So is this a man-made situation? No, it's a God-made situation. It's how it works. Yet, because people don't like what it does, there have been people trying to say we need to be able to stop El Nino. And so the suggestion to get rid of it was to put a huge iceberg on it. And did you guys see this? The iceberg would have to be 33 feet thick and the size of the continental United States. I don't think so. Okay, it's a natural phenomenon, and I hate to say it, but we need to learn to work with it because it is a natural phenomenon. And so I just wanted you to understand that because it really does affect. And it shows how the wintertime patterns are changed. And did you catch it that El Nino and La Nina affect the jet streams? And remember, we'd already learned that the jet streams are above the weather, but they kind of pull the weather or push the weather in different directions. So you can see how as El Nino and La Nina affected the jet streams, it affected the weather in different places, didn't it? So, so that's showing you La Nina, where the winds are pushing the warm water away and it allows the upwelling to come up. And somebody tell me, why did they name it El Nino in the first place? Do you know, you guys know El Nino means the boy child, right?
Yeah.
What boy child? Do you guys know?
Christ child.
Yes, it was around Christmas time. And so that's why they named it El Nino, because they happened around Christmas time. And so then when they got the opposite, which was the cold water, they called it La Nina, which means the little girl. So it was the opposite. And this just shows you, this is in 1998. That's that particular El Nino. And then the La Nina that follows.